All right, so this is going to kind of be like a fireside chat about vibe coding. I've been vibe coding pretty much exclusively for like the last 2 months, and it's incredible, but it can get you pretty good. So this is going to be like how to not suck at vibe coding. So Albert Einstein's got that famous quote that says like, if I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about the solutions. Well, Albert, meet 2025, where we spend 5 seconds copying and pasting a vague prompt and 55 minutes wondering why our app just summoned Cthulhu instead of sorting an array. It turns out that vibe coding is actually just coding, but with vibes. And therefore, all the principles of good coding still apply. You just have to learn to communicate them effectively to your new AI pair programmer. So, strap in. Here's the art of not being terrible at vibe coding. So here's where most developers mess up. You try to have AI one shot implement a feature that you can't even describe correctly. Instead, try this 3-layered approach for prompting for better results: specification, implementation, and verification. So layer 1 is specification, which is the product owner level. There's an old joke on LinkedIn where a product owner says, "I wish my developers would be my pallbearers so they could let me down one last time." And a developer who responded with, "Well, at least these requirements are clear." And it's true. There's few things that developers love to complain about more than unclear or incomplete requirements. But then in the AI world, we just turn around and feed the same vague prompts to AI that are actually even more vague than what our product owner came up with and wonder why the results are bad. Here's the thing. It's okay to be vague with AI at first, as long as we're not implementing yet. We can explicitly say to AI, "I have to implement this ticket." Put your ticket description and your acceptance criteria. But before we start coding, help me think through the requirements and edge cases. We are trying to build a specification right now for implementation later. AI will do a pretty good job of teasing out the requirements beforehand and may help you think of things that you didn't think about before. Oh, pro tip, if you do this before refinement meetings, people will love you. And other pro tip, if you're working in an enterprise environment, there's usually like a ticketing system that oftentimes have APIs. You can actually get your current ticket that's assigned to you in the current sprint and grab its description and acceptance criteria and copy them to the clipboard. And then you can just paste that as your context for a good starting point. So this specification step is foundational, and it prevents your AI from suggesting technically correct solutions, but because you didn't explain the problem correctly, it's a business stupid solution. So make sure that you spend a lot of time on specifying and teasing out exactly what you want to have happen from a business point of view. Once you have a business specification, no technical details yet, that you and Copilot have agreed upon, you can move on to layer 2, which is implementation. So layer 2 is like the tech lead level, which is where you marry business context with technical details. Remember that AI is basically a genius with short-term memory loss, or AMNI, I forget the word. Anyways, it forgets everything outside the current conversation, so you have to remind it of your technical context every time you start a new session. Luckily, there is a way to do that automatically through the .github/copilot instructions.md file in your repository root. This file will get auto-included by Copilot on every single prompt that you have. The Copilot instructions file should reflect, first of all, the business context, which is what your app does, and then also have like the technical stack details, which would include something like the front-end, back-end frameworks, databases, and in my opinion, most importantly, is the project structure, which is, you do have a well-organized project structure with modules properly sorted by technical concern, right? Right? This is particularly important because as your project grows, you start to write your own libraries for how your app deals with common problems. And if AI doesn't have that context, it will break dry or don't repeat yourself and keep resolving the same problems that you've already solved, but in different locations. And as you start repeating yourself more and more, that becomes extra code that starts to drift. As that code starts to drift, it becomes harder to maintain, and bugs will start creeping up in one location but not the other. And it's just a bad time. Make sure that you have a description of like what folders contain what types of files and specifically what technical category they solve. For example, the services directory contains business logic, the controllers directory contains express route handlers, the models contain database schema, the DTO contains data transfer object, middleware contains express middleware, etc. You should also have a section in your Copilot MD file about coding standards and best practices. So that would be stuff like we use Prettier, we use ESLint, we use Pyrite, whatever you use to make sure that your code is working pretty well. Another thing that you should probably do is have a section on running tests, linters, and any kind of commands that are useful. Remember earlier when I said you can write an alias to get your ticket project description? You could put that alias into your Copilot instructions MD file, have a convention with your team for like, this is an alias that we should put in our ZSHRC, assuming you're Unix based, and if you're not, God help you. But assuming you're Unix based, and then you could have Copilot run that at the beginning of implementing a new feature and grab the context and the acceptance criteria automatically from your ticketing system. Pretty cool. It's kind of like a poor man's MCP. So assuming you have all that set up correctly, you can now start implementing the feature you've specified in layer 1. However, just because you have a good business specification doesn't mean you're ready to implement just yet. You should still ask AI to help think through the technical approach before we start coding. This is where we need to specify the specific files as context and ask AI to generate a few technical implementation plans with their pros and cons so that we can choose the one that best fits our use case. The point here is to help you build a mental model of what AI is going to do so that you can kind of start to figure out which files are going to be edited and what the diffs are likely to look like, so that when you code review AI, you actually have a pretty good reference point and context to figure out if AI did it correctly or if it should do something else. You can also weigh pros and cons for different approaches and figure out, okay, do I want to take this tactical approach because this code is likely going to get deleted in a little bit and it might add a little bit more technical debt? Or is this logic really core to my application that needs like an actual refactor right now? Those decisions are yours to make, and you kind of are functioning more like a tech lead, and so that you don't have to worry too much about like the specific implementation details. Like you don't have to worry about the actual coding part. Copilot will handle that, but you get to make design decisions and do more code review than actual coding. So once you have the implementation plan that you like, and you have a good idea of what files will be modified and what the solution, or how the solution will work, you can finally let AI like implement the plan. So we already did a lot of work getting a specification, a business specification, getting a technical implementation plan. Those two things right there should probably take you at least 10 minutes. Probably closer to 20 to 30 if you really want a good one for a sufficiently hard problem. Now, assuming AI has implemented the plan, you're ready for verification. Layer 3 is verification, which is kind of like the QA engineer level. This is where we test, and more test. So assuming you have a working implementation, it's time to make sure that it actually works, not just that Copilot thinks it works, and it doesn't break anything else in the code base. We should specify in our Copilot instructions file that all code changes do require unit tests for verification. The cost of writing unit tests, I used to think that there was kind of a trade-off because it does take human effort to maintain unit tests, or it used to before vibe coding. Nowadays, like the cost of writing pretty good unit tests is so low that it's almost like stupid not to have them, and it actually boosts AI's capabilities considerably in terms of being able to verify its results. And especially now that you're switching to a more code review centric rather than code writing centric, if you ask AI to generate unit tests, you can start there for the code review. You can start looking at like, what is it mocking? What are the inputs and outputs? And figure out like what the assertions are. So if AI gets an entire test suite to pass, you can go read that and have a really good frame of reference for what AI just did. Another really cool thing is that AI agents can read from standard out. And because it can execute commands, like Copilot can actually execute commands in your terminal. It can write a test file, execute a command to run the test file, read the output from standard out, gather failed and passed tests, and then figure out from there, like start to reason about that. Figure out like, oh, well, this test failed because this assertion failed. So if this assertion failed, therefore this might not be true. This is where I should look next. So Copilot can actually use that to figure out the proper context and start to reason about the code. There is one kind of gotcha that AI will have here, is that sometimes AI will write tests that pass with how the code actually works and not how it's supposed to work according to the business specification. I've run into this multiple times for like trickier requirements that I'm trying to implement, where AI will write tests that pass with what it just wrote, but when I go in and try a real world implementation, it'll completely brick, which is where you as a QA engineer / developer can say like, hey, you wrote all these tests that pass, but I tried with this specific scenario. And maybe you're like in the browser console, checking the AI or the request responses and requests, and you can actually capture a real world scenario with real data, obviously de-identify it if you have to, and then say, write a test case with this specific case and assert that it still holds, because I just tested it and it didn't work. And then you can have AI write a failing test, and that way it can be like, oh, I see why this is failing now. Let me go fix and investigate why. So it's not something that like AI can do completely by itself, because we've all been in code review and seen a test that we're like, yeah, I see that you wrote this test here, and that it passes, but it doesn't actually test anything. A test is only as good as the assert statements and as good as the test plan, I suppose, of like where the inputs and outputs are for the interfaces that are under test. And I've definitely seen my fair share of tests where they mock everything and don't leave any unit under test. And if you mock everything, then you're just mocking me at that point, right? Like, yeah, I know that if you mock everything in your app, you can get tests to pass. The whole point is to leave at least one unit under test that's not mocked, so that you have the actual test implementation and you can verify that it works correctly. So anyways, once you have written a test that fails because of a bug, Copilot can just pretty much go through and fix it and use that additional context. And work really hard, by the way, on your regression test. This is where if you find an issue with manual testing, go through and like really figure out what happened, and start to reason like, okay, here's the changes that Copilot made in this implementation. What exactly is it about this implementation that is likely to have caused it to fail? And before you ask Copilot to fix anything, again, it's much better to try to use Copilot to understand the root cause rather than use Copilot to fix right away. Because again, Copilot, as you're dialoguing with Copilot and you're understanding what it's saying and it's generating more context and more reasoning, it's actually generating its own context within that chat session, which will make it more likely to be able to diagnose the root problem correctly. So basically, you can use Copilot as like test-driven development on steroids. You can kind of try to like mix the order of layer 2 and layer 3 if you want to get a little saucy with it, where you say like do the Uncle Bob red green refactor type approach, where you're like, write a test first that's failing, then implement the minimum amount of things to make it not fail, then go back to the test and make it fail again, write some assert statements, then go back and write the implementation to make it not fail. This whole like unit tests and agentic AI for coding, it's way better than anything else that we've ever had, and it makes tests even more important. Oh, and another thing that makes tests even more important is as you write more and more code, like Copilot will be able to write code faster than you've ever thought possible. But because of that, it's more likely to introduce bugs faster than you ever thought possible, and it only has the context for what it's working on. So if you have a instruction to like, once you think you're done with a feature in your Copilot instructions.md file, once you think you're done with a feature and you've tested the unit test for that feature, run all the tests to make sure you haven't broken anything. That way you can see if you accidentally stepped on your own toes at some other point, because it's not that hard to write a feature that works. It's tricky to write. It's a lot harder to write a feature that works within the context of your project, uses the libraries and design patterns that you already use, and doesn't break anything that's existing. Everyone, like testers, never always are like, why is it that whenever you write a ticket, something else breaks? Well, the answer is because there's a lot of dependencies. Code is convoluted, and even good code is tricky to reason about. And when you're so focused on getting a feature to work, it's hard to think of the entirety of everything else that has to work. And that's where having a really good test suite is really important. So there you go. Specification, implementation, verification. Write a really good GitHub Copilot instructions.md file to be able to give Copilot all the context that it needs. It'll cure its amnesia to some extent. You will have to supply file context for as part of the implementation plan. So like as you're specifying to Copilot in the implementation, you can specify which files you anticipate will need to be edited. Ask Copilot questions. The more questions you ask Copilot, the better the results will likely be. Again, think of Copilot as a really, really smart intern that you don't have to pay nearly as much, that also has amnesia. And the Copilot, oh, hey, I remembered that word. Good for me. And Copilot, the Copilot instructions kind of cures that amnesia. And then remember that like vibe coding, it really is the most magical thing that has come out in software since I've been alive. But at the same time, it's not magic. Like if anything, it amplifies all the good software engineering principles because it can do everything way faster, including the bad things like creating tech debt. So good software engineering principles will help like keep tech debt to a minimum. And you can use AI as a pair programmer that can pretty much take all the implementation details away from you. And you get to function as more of a product owner and tech lead, which I think is way more fun. But then there's a third thing. I'm speaking as someone who is a tech lead, and I've been doing this for like 9 years professionally. So my coding skills are actually pretty solid at this point. And I was brought up without Copilot or AI. So we had, back in my day, we had to slog through by hand in Vim. You know, we didn't have we did have autocomplete. That was something that I've never been willing to forego. But still, like programming without AI, there's going to be an entire generation of coders that are coming up that don't know what that's like. And it's not clear to me at this point whether or not that's a good or bad thing, but I know for sure that if you're being expected to meet deadlines at a rate that is much more reasonable for someone that has this superpower, that people who are brand new to the field aren't going to be able to develop the same level of technical skill, likely, as they would by coding by hand. And who knows, maybe AI will get so good where they won't need that. Maybe coding by hand is the new assembly code, where at one point you couldn't be considered a coder if you didn't know assembly. And now with higher level programming languages, which is probably the most, significant innovation before AI, that you could actually code without knowing assembly because it was a different layer of abstraction, and that layer was sufficiently well defined that you didn't actually need to have assembly skills. It's possible that Vibe Coder will just be a profession like that, where you'll have entire groups of people that can completely code with just using AI and just get really good at writing technically rather than actually knowing the technical implementation. But the problem with that is that if everything's a nail, or if you have a hammer, everything becomes a nail. And if all you do is vibe coding, you can get into this mindset of like, small changes that you could need to make by hand, you try to vibe code your way out of, but you will get to a point where you start to lose the context and you can no longer specify exactly what you want anymore. And for small changes, like that's where AI sometimes can mess up. Asking AI to make a small change without sufficient context, it's not a recipe for success. And if you can't, like, if you AI your way into a hole, the only way to get out of that hole is to AI your way out of it if you don't have the technical skill. Whereas I've AI'd my way into a hole and been like, oh, I'm stuck. This is bad. Okay, let's just see what AI did. You know what? This is stupid. I don't like the way AI is doing this. I'm going to code my way out of this. And yeah, so that's my conclusion. Make sure that you specify stuff well. Make sure that you are using AI interactively and don't one-shot things. Try to use it to develop that progressive specification that gets progressively more and more specific, starting with the business context, moving down to the technical details and the technical implementation plan, and finally the verification for how you know everything works, complete with unit tests, and also a lot of manual testing as well. And yeah, just have fun with it. It's an incredible tool, but don't let it take away your ability to develop as a software engineer. Don't let it make you stupid because you can over rely on it and it can become a crutch. I still think you're going to need to be able to program. I still think that you're going to need really good design pattern understanding, because otherwise you won't be able to develop the technical vocabulary for Copilot. So again, try to code by hand. If you're a brand new grad and you're vibe coding, make sure at the very least that you understand why Copilot's doing what it's doing and if it's lying to you or not, because Copilot does lie sometimes, or sometimes it'll tell the truth, but you won't have the proper taste, the software engineering taste, to know that what it just did was incredibly stupid. And the only way that you kind of develop that, I think, is by not over-relying on AI and allowing yourself to be less productive than you potentially could be otherwise. And lastly, to managers, if you're managing juniors like that, try to make sure that they're not stinting their growth in software development by an over-reliance on AI. They will be more productive in the long run if they allow themselves to struggle and don't just try to use AI for everything. Basically, the goal is to become as productive as possible, not to be as productive as possible, because there will be a ceiling for how good they can get if they only use AI. So yeah, that's it. Let me know what you think in the comments below. That's all.